Are you guys seeing my screen?
Yes, sir.
Yes, sir.
All
Yes,
right.
sir.
So when we talk about geometry, we also talk about what? Angles. We talk about different types of angles. All right. As you can see, we have what? Different types of what? Angles, that's true. All right. So as you can see, we have what? Acute, right, obtuse, straight, reflex, and we have a full angle. So an acute angle is what? Is less than 90, not true, but I think something is missing. It should be between 0 and what? And 90. All right, so as you can see, we have what? A right angle, we have obtuse, straight, reflex, etc. So the same thing goes for what? Triangles, not true? So
Yes,
we
sir.
have a right angle, and we also have a what? A right angle what? Triangle. We also have what? Acute angle, and we have acute what? Triangles. All right. We also have different types of triangles called equilateral. Can someone tell me something about equilateral triangles?
Three
Sir, the
sides
equal
of
sides
three
are
angles
equal.
are equal, sir.
Right. And in an isosceles, as it says, what? Two sides
Two
are what?
sides are equal.
Are equal, right? Now, in an isosceles, the internal angles of a
Sorry, can you
triangle
send
measure what?
that in the group?
All right. I'm not hearing you.
You can send this that you're reading from in the group, you're explaining from in the group.
You mean the slide?
Uh-huh.
I will try. It's a PowerPoint. All right. I will try.
All right.
All right. So in an equilateral triangle, all sides are equal. Now, if all sides are equal, all angles are what? Equal. In an isosceles, two sides are equal. If two sides are equal, two angles are equal. And anybody knows that when you add up all the sides, all the angles in a triangle, what do you get?
180.
180.
180.
Right. Good. So these are some basic concepts about triangles and angles, and you shall know these things. All right. So another type of angle is what we call complementary angle. So basically, what this is saying that when two angles add up to give you 90 degrees, they're called complementary. So for example, 50 degrees plus 40 degrees will give you what? 90. So any two angles that add up to 90, they're called complementary angles. All right. Next thing, we have what we call supplementary angles. So when we have two angles that add up to 180, then those two angles are called what? Supplementary. So for example, 140 and 40 will give us what? 180. All right. So we have, I was working on PowerPoint, but boy, I ran out of slides and of notes, sorry. So we have another type of angle called vertically opposite angles or intersecting angles or X angles. And basically what it's saying that vertically opposite angles are equal. So 75 is
So, sir,
equal to what?
opposite sides are equal, sir.
Yeah, vertically opposite angles are equal. Okay, so for example, if you have an X, anything that shapes like an X, it means that the opposite angles are equal. All right. Can someone tell me how they get? How you think we got 105?
Sir, I guess you add up 275 again.
Because they are straight lines.
It's a straight angle, right? So if you look, let me see if I can mark here. So if you have a straight angle right here, it's a straight angle in the room. And let's go back here. A straight angle measures what? 180, right? So if you look at this, if this is 75, to get over here, it would be 75 subtract 180, which is 105. And if over on the right hand side is 105, over on the left hand side must be 105. All right. Question: if I add up all these angles, what number would I get?
360.
360. All right. So let me. All right, so we have some other types of angles. Let me see if I can find. A minute there. All right, so we have something called alternative angles. Or Z angles. All right, so anything looks like a Z. So these two arrows is saying that these two lines are what? Parallel.
Parallel.
All right, so when you have something that looks like a Z in the form of and two lines are and they have two arrows, it means that these two angles are equal. So if this is 30 degrees, this must be what? 30 degrees. But they can only be equal if they are parallel. And how you know if they're parallel? Is that they tell you that they're parallel or they give you the arrows? Right? Which other letter in the alphabet looks like a Z?
N.
It will be an N, right? So it could also look like this. All right, so that's an N shape. So alternative angles are basically what? Equal. All right. So guys, I'm just running through some things that you should have probably known from a long time. So we have vertically opposite angles. We have alternative angles.
Corresponding.
Right. Good. So we're getting there now. So we're going to get in to this now. All right. All right. Question. Do you see a Z shape in this figure here?
Yes, sir.
Yeah, it's there, Andrew. So it's this, right? That's our Z. So would you agree with me that these two angles are equal?
Yes, sir.
So those two angles will be equal.
Yeah.
Right, very good.
Sir, what about if it was the other side, to sir? It would be equal.
You mean like over here?
Yes, sir.
Well, yes, these two will be sorry. Yeah, these two will also be equal.
So how would they find this?
Hmm?
Oh, okay.
All right. So if I have an angle here, say A, B, C, and D, E, F, G, and H. All right. All right. I need someone to tell me the angles that are equal.
A,
A
E,
and
B, A,
and
All right.
B,
What one?
A.
BF
Okay. So A is equal to
E.
A is equal to E. Right. So basically, A is equal to E because they correspond. All right. And D is equal to what?
A.
A
H.
because they correspond. B is equal to what?
F.
F because they correspond. And C is
G.
equal to G
G.
because they are corresponding angles. All right. All right. Now, is A equal to C? Are these two equal?
no, sir.
Sir, I
Yes,
would say
sir.
they're equal.
They're equal.
They are vertically
Sir.
Isn't this an X? Look at this. It's an X,
Yes.
Yes,
true.
sir.
Right.
Yes, sir.
So they are what? They're vertical. They're vertically opposite. So A is equal to C, and what? B is equal to what?
Equal D.
Equal to D. E is equal to what?
G.
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 And F is equal to what?
H.
H. And what's the reason? Because what? Vertically opposite angles are what? Are equal.
Equal. Sir,
Yes.
I don't understand the first part, sir. We say at the top, sir, about complementary
You mean
angles,
corresponding?
sir.
Corresponding?
Corresponding. Yes, sir.
Right. So all right. So look at A. A corresponds to E. Hold on. All right. So A corresponds to E. B corresponds to F. And C corresponds to what? G. And D corresponds to what? To H. All right.
Yes,
Let me
sir.
ask a question. Is D equal to F? If so, why?
Yes, sir. Yes, sir.
What's the reason?
Yes,
Alternate.
sir.
Z
That
because the
corresponding.
Z angle
Right. All
alternate.
right. Z. Please don't go to the exam and say Z angles here.
Z
All right.
alternate.
If let me tell you, what if you can't remember alternative angle, what you're gonna do is put Z in captions and say Z shaped angles. All right. Everybody get this? All right.
Yes, sir.
No,
So I'm not expecting anybody to be actually writing, all right, because this is like stuff you did in grade 10. or some time ago. All right, so I pressed something a while ago. I don't know what's happening. I guess the whole storm thing was a hoax. No? I don't think a lot of person from this side actually felt it, right?
Sir, maybe I didn't feel it, but you have like Kingston and Olaf.
Right, Kingston and St. Thomas. Yeah, man, I know they feel it a lot. All right, look at this. All right, so I
Sir,
have
there are two.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. All right, look at this now. So I'm gonna ask you a question, and you tell me what is equal to what. All right, but this is like a lot of work. But as you can see, it's something similar to corresponding angle, don't you? It's just we add another what? Another layer of line to the right. All right. So, question: is G true or false? Is G equal to L?
True.
True. What's the reason?
Yes, sir.
Alternating or Z angles, as some of you say. Right. Cool. What about true or false? Is I equal to M? Sorry, not M. N.
True.
True.
True. Right. What's the reason?
Vertical opposite
Vertical and
angle.
opposite angles are
Yes.
equal. All right. Cool. All right. Next question now. Is E equal to O?
Yes, sir. No.
No, sir.
False. No,
It's
sir.
false. It's false. That's true.
False.
Yes,
Yes.
sir.
E is actually equal to what?
Okay.
K. Right. So they don't correspond. Is A equal to E? Is A equal to E? True or false? Actually, true.
True, sir.
Yeah.
Corresponding, sir.
Yeah, they're corresponding. Yeah. Is it just like how A corresponds to I? A also corresponds to what? To E. Likewise, B corresponds to what? F.
F.
Right. Let me see if we can do one more. And remember, guys, that these two lines have to be what? Parallel. And how you know that they're parallel? The arrows. So the arrows tell you that they're what? They're parallel. All right. Is M equal to P? True or false?
No, sir.
It's false, not true. M is actually equal to what?
Oh.
To O. All right. So you have to look out for that. All right. So these are some general concepts about angles on a straight line. All right. Let me go to one more thing. All right. Let's look at a question before start. Let me stop share for a moment. Are you guys seeing that? My screen?
It's small,
Yes,
Mr.
sir.
Stevens. Yeah.
All right. Look at question number 4. So the question says two angles are supplementary if one. Oh, there's an error. Oh dear, hold on there. There's an error in this thing here. So this 5 here should be 2. So this should be 2x. All right.
Sir.
Mhm.
Oh, no worry.
You wanna say something?
I was asking if we must do it.
Well, what is coming into your head? Yeah, man. I want you to attempt it. All right. Anybody, how do you approach this question? What do we know?
Angle on a straight
Angle
line.
in a straight line equal to
Measure
180.
180, not true?
Measure 180.
All right,
Yeah.
good. So what does that say about all of this?
Everything must add up to 180.
Right, everything. So in other words, the 36, the 2x, and the x was up to what? 100 and what? 8. All right. So basically, they want you to find what? What is x? Not true. So how would you do that? But this is algebra, not true.
Yes, sir.
So can I add these two?
Oh, sir.
No, because they're online terms. So we're going to add what? We're going to add these two terms. So we get 36 plus what? What's 2x plus x?
3x.
3x equals what? 100 and what? 80. All right. Can someone tell me what to do next?
So I would
Sorry, one.
bring
6.
that'd be 180 minus 36.
Right. You subtract 36 from the left, and you subtract 36 on the what? On the right.
Right.
So you're gonna end up with what? 3x. And what is 180 minus 36?
144.
144.
4. And what do we do next, class?
Divide both sides by 3.
By 3. So what x equal to?
40.
48.
48.
X is equal to 48. But let's answer the question. It says, what is the measure of both angles? So we know that x is what? 48. What is this one equal to? The middle one.
96.
Right. It's going to be 2 times 48, which is what? 96. And class, if you're to add 48 plus 96 plus 36, you'll get what? You should get 180. Can somebody check that for me, please?
Yes, it is.
All right. Very good. All right. Any questions? All right, let's look at another question. All right. Wow. All right. So this looks let me give you a few minutes to just digest this. Don't try to draw this diagram here. Just look at it. All right, so sometimes when you see these questions, you're tempted to look at, okay, so the question says to find x, y, and z, right? So sometimes you're tempted to zoom in on x, you're tempted to zoom in on y, you're tempted to zoom in on z. But my suggestion to you, you zoom in on the whole thing, all right? And sometimes when you see a question, you don't know what to do, you start off by writing on stuff that what you know, all right? Now, what do we know from this? Apart from finding x, y, and z, what can you get out of this? What do you see? And what angles are equal?
Sure, one Z today.
Right, right. And big O Z, not true? Or it could be an N, not true? Yeah, could be an N. All right. And are these two lines parallel?
Yes,
Yes,
sir.
sir.
Yes, they're parallel because the arrows indicate that they're parallel, not true? All right. Which two angles are equal? All right, let me
Z and
ask you.
X, me no know.
All right.
Z and X, X and Y would be equal.
No.
Let me tell. No, Jody, let me tell you. It's the only way X and Y could be equal is if. No, Jody, look. Is this X here, sir? This angle and this angle are equal. So both of these are what? Equal. You follow?
Yes, sir.
Right. Can someone tell what this angle is?
A right angle. A right angle?
It would be 95.
It will be 95. No, it wouldn't be a right angle. It will be the 95.
Sir,
True.
repeat.
All right, come again. I'm asking you what this angle down here is equal to.
$95.
Wouldn't it be 95? Wouldn't these two correspond?
Yes.
Yes, sir.
Yeah, they would correspond, right? What about this angle inside here, sir? What is that angle?
Why?
All right, you're saying it's Y, but guess what, man? I would remember saying no. This is look at it. This is the Z, right? It says inside this area here, the creases. So notice the crease is right here. So I would say that this Y and this Y will be equal, but not. I'm talking about right here, so a little part here, so beside the Z, opposite side of Z. What that equal to?
So would it be 95?
It will be 95. Yeah, why?
I'll say it
Corresponds.
would correspond with 95
It
over the
corresponds.
other side.
Look. So if this is 95, then this must also be what? 95. Y'all see that? All right. So question, if this over here says 95, class, what will be Z equal to?
85.
85. How you get 85?
It's on a straight line,
In
you
a
know?
straight line.
Right. Very good. Very good.
Really? It's not.
Sir, repeat why it's 85.
All right. Let's go again.
Not right.
If this is 95,
Times 2.
then this piece is what? 95. Agreed? And so this is a straight angle, right? That's a straight angle, which measures what? 180. So to get Z, it will be 180 subtract 95. Which is 85. So Z is equal to 85.
So, sir,
Mm-hmm.
may I ask a question?
Yeah, man.
So, A to B is not a straight line, right?
Come again. A to
A to B. Is A to B a straight line?
yes. Come on, it's a straight line.
So,
If it's not a straight line, it's a curve.
so the principle that says that angle on a straight line is 180 does not apply here then? That's what
Yeah,
you're
man.
saying?
Yeah, man, but that's what we did. That's what we said. To get Z. Because over here it says 95, you know. And we say that angle straight line is measure 180. So we say 95 from 180 gives you 85. So that's why Z is equal to 85. That's the principle that we use to get the 85. Who can tell me what you think X is?
$85.
All right, hold on. So we said that Z is 85. You want to give me the logic?
Alternate angles for X if X is 85.
Turn it. You're talking about Z angles?
Yes.
Yes, correct. Very good. You all see that, guys? Z will be equal to what?
Yes.
X, not true?
85.
Right. So X is equal to 85. And the reason is because what? Alternative angles are equal. So X is also 85. All right. How are you going to find Y now? Just take your time and look at the diagram. Notice that Y is inside of a triangle, not true?
Sir,
Mhm.
could we use the 50 degrees up there, so sir, to get what y is, sir? Because if there says 50, then right in another little corner there, so you just say a 50.
Right, very good. Very good. So let me try to draw this a little bigger. Why is inside a little corner 50, by the way? What's the reason?
Sir, what call that again? Vertically opposite angle.
Right. So if this is 50, inside it must also be what? 50. All right. But I bet I'm gonna draw it. This look more terrible. But that's not why. Not true. So what you're saying that right here, so
Would be
that little space there is what? Is also 50, not true?
yes.
So if you can figure out the angle over here, so you can add that angle plus 50, then subtract it from 180 to get Y, not true? So how would you determine this angle right here, sir? Is it 85? ask, what is this angle here? It's 85. So,
85,
right.
sir.
So we can find the what? The other piece in here, so don't you? 85 from 180, which is what? 95. All right. Or let me show you something. This is 95, isn't true? Up here, so. So this is also what? 95. And this is another x, not true? So inside there must be 95. So we have a triangle like this. We have 50. And we have what? 95. And we have y.
So y is equal to 35, sir.
So that's going to be 180. Subtract the sum of 50 plus 95. Can somebody second that? Is that correct?
Yes, sir.
Right.
Yes, sir.
Right. Any questions? All right, let me see if we can do one more like this. All right, look at 6. I'm going to give you 5 minutes to try to figure it out on your own. Or guys? Anybody with any thoughts?
Sir,
Mm-hmm.
for angle X, at the top there, sir,
Mm-hmm.
could you say it's an acute angle?
Um,
Or would you say it's a straight line angle just the same?
But it said it's a straight line.
you're
It's on
talking
a straight
from.
line, but it's not.
Mhm.
It's on a straight line where the 30 degrees would come in, but based on how it's set to me, sir, it look like it kind of acute, so it wouldn't be like 90 or so. It kind of,
All right, Jody.
uh,
Jody,
yes, sir.
you see that? What does it says?
Yeah. Yes,
Not
I'm not
drawn.
trying to see
Not drawn
it,
the
sir.
scale. So you can't look at it, and they don't want you to look at it and say, "Boy, my fees." It's not. It's not like that. So I see what you're saying. What this would be a 90, not true. So what you're saying? It's 80. All
So the
right.
first thing I would do is try and write an expression.
Mm-hmm.
So I would say
Mm-hmm.
30 plus 2x plus x is 180 because they did say that AF and CH are straight lines. And they said that BG is parallel to DE. So after writing,
Hold on. You'd say x plus 30 plus 2x is equal
yes,
to 180. All
yes.
right. Let me tell you something. That is true only if it was like this. If all of this was x. If all of that was x, and that was no, it wouldn't work either.
All
It
right, so
wouldn't work.
let me ask you a question then, sir.
Mm-hmm.
X is not 50.
How do you arrive at that?
The same principle that I just told you because they said
Mm-hmm.
they said that CH is a straight line, sir.
Right. C to H is a straight line, right?
And they said that an AF as well.
And an AF, right, is a straight line. Mm-hmm. All right. No, I don't think that approach. Yeah, I mean,
So here it
mhm. Hold on here. Let me try to resolve. Let me try to clear this up. So CF is a straight line, right? And CH is a straight line, all right? But the thing about it is that if you look at CH, right? I mean, 2x is actually over there. So because the angle is right there, it forms an angle which is not straight. So I'm saying, and if you look at where x is and where 30 is. So this is the shape that we're working with.
Sure.
And if you look at this shape here, that is not a straight line. All
Okay,
right.
so
So that's the logic behind why you couldn't say that. All right. Somebody else was saying something.
never mind, sir, never mind.
All right. Class, what did I
Sir,
say? Mm-hmm. Yes.
what what I did is drop an
Mm-hmm.
equation. Or what
Mm-hmm.
I did was drop an equation.
Mm-hmm.
So I said, because BG is a straight line
Mm-hmm.
and AF is a straight line. What I did
Mm-hmm.
is to press um 30x. No, what I did?
Hold on. 30 plus 2. What I did was 30 plus 2x equal 180.
Mm-hmm. Who you
Then I
get
go
that?
on
Who you get that?
because angle in a triangle add up to 180, sir. So I work out the inside of the triangle first.
Oh, so
Also, the
Audrey,
side
you're saying that
of
this is equal to 30. That's what you're
yes,
saying, right?
sir.
Right, very
Yes,
good.
sir.
So that's how you're gonna start the question. This is a Z, not true?
Yes, sir.
Right. So if this is 30, then this must be 30. And then this is a straight angle. So if over here are 30 and all over here are 2x, it means that 30 plus 2x is equal to 180. Very good. That's how you reason it out. So this definitely is a straight angle. So I can definitely say that what? It is equal to 180. And then you solve for x. Mind you, you might get 50, you might get 50, or you might get the same answer, but you have to reason it out logically. All right? Suppose you get the
Okay.
same answer and you ask to go to an audience explain this and you explain that. All right. So Audrey, how you work this out, Audrey?
Yes, sir. What I did was to um 2x equal 180 minus
30.
yes.
Mm-hmm.
So let's equal 150.
And what's 180 minus 30?
150.
No, yes, sir.
Then you divide by
One one, minus 30 give me 160
so what's the
75.
answer?
divided by
75.
2.
75.
It will be
Sir.
yes?
Okay.
So x is equal to 75. Any questions?
Sir, probably like I'm not sure. I thought somebody was saying like 30 plus 2x and the x probably if I did it like that I would have gotten the answer, but I did
Got
it
it
other
correct,
way
right. Okay.
discussing it.
All right. How are we going to find y now, class?
Sir,
Mm-hmm.
I probably I don't know how to explain to somebody, but what I did was I found that inside where you say 2x, inside the angle there, I got
Mm-hmm.
30. I got 30 for that angle inside. And
Which angle inside?
well, it's not there, but that's how I work it out. They don't have the angle there, but I work it out on the straight line where H is.
Mm-hmm.
So
Okay, okay. Mm-hmm. Yeah,
yes,
it's actually 30, right? It is 30.
yes. And then I minus the 30 from the 180, and then I divide it into,
Y2.
yes, so that's how I got 75 for Y.
Y divided by 2.
Sir, because it's a triangle, sir, inside there, so sir. So if I find one for y, I would have to say that's an angle there, and where f right there, so on the straight line where f is, sir, that would be another angle, sir. So I divide it by 2.
Why 2? And why not 3 or 4 or 10?
Sir, because I want triangle, sir, I already have one angle already.
Yeah, but you only do that if it's an isosceles. Because then you'd say that the 2 angles are equal. All right, let me show you something. If you have a triangle, right? If you have a triangle, and you only know one side, so we know so this angle is 30. No, we don't know what this side is, and we don't know what that side angle is. All right. So there's no way you can actually find out what this angle is and that angle is if you don't know what the other angle. And you can't say boy divided by 2 unless it's a what? An isosceles. And that's what you do when you have an isosceles triangle. All right. Anybody else? How do you figure out why?
So you already figured out what x was in the triangle, which is 75. So one angle is 30, you have y at the top, and the other angle would be x, which is 75 there. So you add 30 and the 75 plus y equal 180. And then
Why is it equal to 180?
because the triangle is equal to 180.
Oh, you're saying that you're saying that inside here is what? 75?
Yeah.
Why is that so? Why is it equal to 75?
Corresponding angles.
Right, because they correspond. Right, very good. Yeah. All right, right. So if this is 75, then this must be 75. All right, Jody? So this is 75. So you add 75 plus 30 and then subtract it from 180. Very good.
And sir, we could say it's on a straight line, sir, based on the 75 and the 30 that we have up there. So sir, so
Very that's where I was that's where I was gonna as a matter of fact, that's the first thing that came to my mind. That all of this is a what? A straight angle, not true? Right. So you could just add 75 plus 30, then subtract from 180. But as you can see, there's always what? 2 different ways of what? Getting this thing. All right.
Sir, you know, say that me do first.
But I'm not gonna lie. I'm not gonna lie to you. I didn't even see that these two correspond because I wasn't looking at that. I was just looking at the straight angle. I just see it just like
so
that.
Sir. So you tell me, sir, you only do it when you have one isosceles triangle. So those two angles down there, so they're not equal, sir. So what would you say? This the y and then you would have 75 there, so for those two angles.
Yeah, but Johnny, it wouldn't work for all triangles.
No,
it's
no, sir, but I'm just saying because it worked out that those two angles would be equal.
All right, so it's just coincidence that because they didn't say it. All right, and the only way you could probably say they're equal is just by if they tell you that it's an isosceles. All right. All right. So y is equal to what, class? It's 180. Subtract the sum of what? 75 plus 30.
75.
And is equal to 75. But Jody, would you agree with me that the logic behind what we're saying is more credible? The reason that I give is more credible than to say just divide it by 2.
Yes, sir. I understand.
It's more credible. Yeah, because you know, yeah. All right, moving on. All right, so let's talk about isosceles triangle. All right, so in an isosceles, right, two sides are equal, not true? Two sides are equal. If two sides are equal, then two angles must be equal. So these two angles must be equal. All right. Now, so for example, if I say this is angle 40 class, that is 40 degrees. And I say find, it's an isosceles triangle, and that's 40. How do you find x and y?
X would be 40 and Y would be 100 because they're equal to 180, and if X
Right.
is equal to 40, then Y.
Very good, very good, very good. Awesome. So because if it's an isosceles, right? And if they tell us this is 40, then x must be 40. What's the reason? Because they're equal, aren't you? And then how you get y now? You add the 40 plus 40, then subtract it from what? 180. Right. And what if I have something like this now, class? Suppose I have something like this. Suppose I tell you that. And this one is for Jody. This one is for Jody. Suppose I tell that this angle here is 140 degrees. And I say find x and y. Jody, how do you find x and y?
Sir, I would minus I would minus the 140 from the 180 because it's an isosceles triangle, and
what?
angles would equal
divide
by
by 2. Right.
Yes.
So the reason why you divide by 2 is because then tell us is a what? An isosceles. Right. So what she says that, so what you notice in this triangle, you know, all one angle they give one angle until you find the other two. But because it's an isosceles, you know that these two angles have to be equal. So it's a 180 subtract 140, and that is what? 40, not true? But because it's an isosceles, we divide by 2. So therefore this must be what? 20. And that must be 20. Everybody following?
Yes, sir.
Yes,
All right. All right. So this is the basic concept. But why? So when I said, well, when you get an exam, something different, don't you? All right. So let me show you the tricky part about this thing. The tricky part about it. The tricky part about this, you see, is what if I draw the. All right. Let's go back to the isosceles again. Now you notice I use those two strokes to indicate that these two sides are what?
Equal.
Are equal. So, and because I said that these two sides are equal, then these two angles are equal. Now class, sometimes they're not gonna make it look so simple. They're not gonna present the triangle to you like this so simple because it's really easy to see. All right. Now, how can you prove? How can you know? So boy, a dongness and dongness are equal. All right, rather than up here. So this is what you do. And I always say this to students, you know, whenever you're in the exam, don't be afraid to mark up the diagram. They're not gonna mark. They're not gonna mark what is on the diagram. They're only going to mark what you write on the part that they say you must write. So don't be afraid to mark up your exam paper. All right? As a matter of fact, sometimes it's better you mark it up because they're saying that, boy, at least you know copy. Because if you get the exam paper and it's clean like a whistle and the only thing you have was it, and then you go, and for this one you go where? You go down, not true? So the two angles that are equal would be what? A and C. Everybody see that? Let me do another one. All right, which two angles are equal?
QR, PR.
All right, good. So you go over there. So R is equal and P. So P and R are equal. All right. All right. Before I go, you see. Before I go. What do you call this triangle?
Right angle triangle.
Yes, you're half right. Boy, you know this. It's 45 and 45, isn't it? So what else do you know about this triangle? Apart from the fact it's a right angle triangle.
It's an isosceles triangle.
It's also what? An isosceles, not sure. Yeah. So it's an isosceles right angle triangle. All right. First of all, you that? Yeah, man. You can have a right angle triangle that's an isosceles. But both the other two sides would have to be what? 45 and 45. All right. Let's tackle a question. Let's look at number 5. I'm going to give you 5 minutes to see if you can figure out this. All right. So after this question, we're going to do another question, and we're going to look at what we call circle theorem. All right. So remember, you guys tell me when you want me to stop, because unfortunately I couldn't make it at 12. However, this meeting is recorded, right? So you can watch it anytime. Let me also say this to you that if that Tuesday, if you're doing English and it's Tuesday, you only really have tomorrow and probably Tuesday night to do some work. All right. I think I'm gonna make myself available Tuesday online to go through a few multiple choice questions. All right. Yeah. But I will keep you posted. All right, 5 minutes to look at this question. And I must admit to you, this question, there's one thing I don't like about this question. if you notice that the 140 right here, so it is the 140 stretches from here to there. All right, please make a note. It's not that little piece here 140. All right, it stretches along that line. All right, guys. Anybody figured out anything? Can you guys hear me? Oh yes, you can. All right. Well, what
Sir.
can? Yeah. Go ahead. Yes.
Sir,
Yeah, man. Go ahead. Yes, Audrey.
write N, sir.
At N, right?
You have a 40 right there, so sir.
Is it all of N or just a piece? Is it this you're talking?
Yes, sir. There says 40, sir.
Right.
And on the
Right.
other side,
All right. Hold on, Audrey. Why is it 40?
because it's an isosceles triangle, sir.
Right. Very good. Very good. And as you can see, that if you're to do the same thing, class, see it? Right. So if this is 40, then this must be 40. Very good. Yes.
Write N,
Continue.
sir. There's 7, sir. Write N on the other the side. Sir, is 70.
The other side.
Yes, sir. 70.
All right.
And
How do you,
total, sir.
how you get 70? Explain to us how you got the 70.
Because 40 is at KL, sir. Is one. There's a 40 over on the other side of the triangle, sir.
All right, very good, awesome. So basically what Audrey is saying is that if both of these angles are 40, is the class? Then this little piece here have to be what? 100, not true? You all see that? Because 100 plus 40 gives you what? 180. Or you could say 40 plus 40 from 180. All right? And then I think what Audrey is also saying is that if all of this is 140 and this, if this piece is 100, then that little piece down here so must be what? Must be 40. All right, and yet again, I believe what Audrey is saying is that these two angles are equal. Not true. Right. So if
Yes, sir.
if this is 40, what she did was say 40 from 180 is 140, then divide by what? By 2. So you get 70 and 70. All right. Awesome, Audrey. That's pretty good. Class, are you following? Any questions?
Yes, sir.
Right. But guess what, no? Guess what? We work out the whole thing, not true? But then we have to learn how to answer the question. All right. No, it says L and K. All right. So, oh boy, this diagram looks so. All right. Let me just work with this. So, let me use another color. Let me use red. All right. So L and K. Where's L to N to K? So that's how you reason it. L, which is right here, to N to K. So they're talking about what? That little piece there. So as you can see, that is equal to what? 40. All right. And then now N to L to M. So N over here, let me erase it. This is N to L to M is also 40 again, not true? And then the last one, K to N to M. So K to N to M. No, K to N to M is all of this. So what is all of this, class? What is K to N to M?
110, sir.
Right, it will be 40 plus 70, which is equal to what? 110. All right, any questions? All right, no, you notice the question says give reasons for your answer, not true? So you cannot have those values without any reason, because each of these questions will probably value what? 2 marks. So that will be a total of what? 6. So if you just put 40, 40, 110, you probably get 3. So let's look at L and K, and let us see if we can find a reason for the 40. So this L to this N to this K. I mean, the reason why we got it to be 40 is that because we reason it out to be that this triangle is what? So KLN is an isosceles triangle. All right, so that's your reason. The reason is KLN is an isosceles triangle. I don't have no space to write the word. So that's your reason. Part 2, N to L to M. So N to L to M is also 40. Now, how do we get the 40? Well, we had to deduce that this angle here is what? 100, not true? And then when we figure it out to be 100, we subtract the 100 from what? The 140 to give us what? 40. But how did we get the 100? We got the 100 because triangle KLN is an isosceles, not true? Is an isosceles. And what you can do is just to do the math. Just write 140 subtract 100. If you're in the exam and you're nervous and nothing is coming, no words are coming out, just write out do some math, do some working out. All right? And that's how they would have gotten the what? The 40. Any questions? All right. For the last one, I say just put 40 plus 70 to give you 110. That would be my reason. That's basically what you did to got the 110.
Sir.
Mm-hmm.
So why include the 40 in the
110 in the last part? All right, good question. The question says to find angle K to L. Sorry, not L. K to N to M. So look now, K to N to M is all of this piece here. So it will be the 40 plus the 70. If it was, what you thought the answer would have been? 40?
Just the 70.
Just a 70. But all right, cool. All right. Look, Jody. You're talking about this the 70 right here, is that true? That's what you're talking about, right?
Yes, sir.
All right, but where's the key? It's all right. Let me show you. This 70 would have been L to N to M. L to N to M. You see what I'm saying? That would be 70.
Yes, sir. Yeah.
So you have to look. You have to look at the first letter. You have to look at all the letters. All right, and you know, Audrey was saying something about N. Look at N, but you know, it's very unsafe to say N, because if you look at N could have go so, N could have go so. You have to be very specific. All right. G. Kirk. All right. Okay. All right. Any questions? All right. Let's look at another one. So after this question, we're going to look at what we call circle theorem or circle theory. And this is not really a pleasant topic, you know. So persons can get really, it can really dry here or their head when you do these questions. I don't know why, but it happens. All right, let's also look at this question here. Question number 9. Let me give you a few minutes to see if you can make sense of it. By the way, you guys notice how when you approach these questions, you try to work with all the numbers first, and then you tackle the question. I think that's the best approach. Yeah. Don't try to tackle the question and try to figure out what is this and what is that first. Just look at the question, and based on our concepts, try to answer all the angles. Try to work on all the angles first.
Sir, how much does an isosceles triangle measure? 180?
Yeah, it's always 180. It's only like one dance to them, man.
Go again?
It's only like one dance to them. You know, like the eco business, like. Yeah, so,
Unfortunately not.
Yes, selector. Pull up. Yeah, all triangles, the internal angles of all triangle measure what? 180. All right, who wants to take this? Take this on. Or any part of it? Yes, Audrey.
Sir.
Audrey, now give nobody's a chance. All right.
ADC, sir.
Come again.
Angle ADC, sir.
Oh, right on yourself. It's 74.
74, sir.
Right, and everybody see why it is 74, right, class? Yeah, man, it's 74 because, you know, it's an isosceles. Therefore, these two angles are equal. Very good. Anything else?
Angle BCA, sir.
BC, you're talking about this, right?
Yes, sir. It's 53, sir.
It is 53?
Yes, sir.
All right, you want to explain?
Angle CAD, sir.
All right, so I guess you don't want to explain. Anyway, yeah. That piece.
That's 32, sir.
32. All right. Yes, and I can see why you get the 32 because you add these two. Is that so? And subtract it from 180. Correct?
Yes, sir.
Very good. Yes. But I want to know how you got. Go ahead. Yeah,
The
continue.
other angle, sir.
Right. You talk ABC. Right. I like how you are correctly telling me the specifics. Right. Angle.
That is 53, sir.
Right. It's 53. All right. All right. So basically, these two angles are what? Equal, not true, class. And I believe what Audrey did was subtract 74 from 180 and divide it by 2. All right. This one is so bad, don't you? All right. So the question says calculate C8. Hold on. Is everybody hearing me? I get the I don't know. I'm having. Is everybody following? I'm only hearing familiar voices.
Yes, sir.
Travini,
Yes, sir.
Hyacinth, and
Yes, sir.
and some other persons. Right. All right. Okay. So, right. Yes. CAD. Where is CAD? CAD is 32, not true? Because look, it is from C to A to D, so it's right here. So that's 32. And BCA. So you look for B, then you look for C, then you look for A. So BCA, so they're talking about right here. So be very careful now. So that's going to be what? 53. All right. Okay. So luckily this question didn't ask for a reason. All right. Okay. Question, class. Angles in a triangle measure 180, right? What if it was a four-sided figure? What would that be equal to?
360, sir.
360. All right.
I observed that it's a parallelogram, sir, so it would add up to 360. All the angles add up to 360.
All right. Let's do one little. Let's look at All right. You know what? Because of time. All right. You know what? Let's look at let's look at 3. The diagram looks complicated, but it's pretty simple. Let me give you 2 minutes to figure it out. All right, class. Quickly, somebody tell me what is A and Y?
Sir, A 69
Right. What's the reason?
alternative angle.
Very good. Awesome. All right. Somebody can tell me what angle B is?
Repeat that for me, sir.
Okay. You mean for A?
Yes, please.
Yes, A is 69 because as you can see, you see the Z shape?
Yes.
Right, and you see the arrows, the two arrows, they're parallel. So when you have a Z shape and two lines are parallel, it means that the interior angles are equal. So if this is 69, then that must be 69. And the reason would have been alternative angles are equal.
Thanks.
All right. What about B class? What is B?
23.
23.
111.
100. All right.
B. Sir,
No
the
man.
B, yes, yes.
Yeah, B as in yeah, B. B will be down here.
Sir, I have 23.
All right. How you got the 23?
Sir, because it's a four-sided figure, sir, so I add up all the angles and minus it from the 360.
Right. Right. Very good. Can I get a second? Can somebody second that for me? She said that B is 23.
Sir.
Yes, sir.
Mm-hmm.
Yes, sir.
Mm-hmm. Okay. Yes, I got a second. Everybody following?
Yes, sir.
It's a four-sided figure. So therefore, the internal angles of this quadrilateral would measure what? 360. So you add 112, 156 plus 69 and subtract it from 360, and that would give you. All right, guys. So we're gonna quickly look at circle theorem, and this can be a little bit intimidating.
Answer B.
Hmm? For B,
Where answer B? Yeah.
23. It's 23, right? Let's let's test it out. Do you guys see my calculator? All right, so 112. No, I'm sorry though. It should be 360. Subtract the sum of 112 plus 156 plus 69, close bracket, 23. All right. Are we good? All right.
Yes, sir.
All right. Let us. Give me a minute. Let me just bring up. All right. So the next topic is what we call circle theorem. And circle theorem, it's really how shapes behave in a circle. All right. So if I have something like this, all right. All right. Tell you what. Let me. For those of you who don't know about this, I'm giving you time to write off this. All right. So Oops. So we're looking at how shapes behave in a circle. I might be wondering, why on earth would anybody want to look at that? Well, if you're thinking about navigation, this is the mathematics of navigation. You know, how you move from point A to point B on a vessel in the middle of the ocean. They use circle theorem to guide them. All right. We're not actually looking at how they actually do it. We're looking at the core concepts of circle theory. All right. So if this is new to you, or maybe you haven't done this in a while, you can take this off. So we just drawing a few circles. This, I tell you, this is not gonna work. I'm gonna need more space. Let me delete. All right, let me just delete this because let me see if I can put it on a slide. Let me draw another one. Guys, see how best you can draw those from here. If you can't bother draw them, just don't take a photo yet. Because I'm gonna have some things to write inside, but it's very difficult for me to write them on a computer. I'm gonna have to write them manually.
Nicole.
All right, so for those of you that have taught this already, I usually call them case one. So change this to back to blue. So this is case 1. You know what? Let me not do that here because I don't remember what case I used to call it. But is this one here? All right. So let me tell you what. Let me tell you how to answer questions like this. By the way, this is section 2. This is section 2 here of your maths paper, not in section 1. All right. So anytime you have a circle and you see something like a little kite or a little plane or something like that, that shape, it's telling us that the angles at the center is twice the angles standing at the top. All right, that's what it means. So for example, if this was, say, 40 degrees class, and you see this shape, what inches is going to be? It's going to be twice, right? It's going to be 80. All right, and the reason for that, you see, listen carefully. The reason for that is angle at the center of a circle is twice the angle standing on the same arc. So you're going to have to write out all of that. So let me put 1, 2, 3, 4. Quiet. 4, 5. All right. I have 2 more to join here. Let me type them for you. So for diagram 1 class, the reason is angles at the center of a circle is twice the angle standing on the same arc. You have to remember that here. Diagram 2. All right, diagram 2 now. Watch this now, class. If you have a circle, right, and you draw a straight line through the center, what is the name of that line? Start with D.
Diameter.
Diameter. All right. Now, anytime you have a circle, and you can try this, you can go home and, so you can actually, so if it was a face-to-face class, you would be allowed to actually prove this. Like you go to class, you take a compass and you actually draw these shapes, and you use your protractor to check to see if what we're saying is true. All right, and it is true. So anytime you have a circle, right, and you draw a straight line through it, and you try to construct a triangle, you see the angle inside here is always a 90. So if I do something like this, class, if I do something like, if I draw another triangle like this, class, look, this would also give me what? Another 90, don't you? Yeah. Or if I do like this, that's a 90. If I do like this, oops, that's another 90. So you're always going to get a 90. So what's the reason now? So you'd say for diagram, what's that, 2? For diagram 2, you'd say for the reason angle formed in a semicircle is let me say 90 degrees. You can say that. Or you could say right angle. Any questions? All right. Let us look at diagram 3. All right. Now, let me show you something. If you have a circle, right? If you draw a line across like that, what's the name of that line? Start with C.
A chord.
It's a chord, don't you? But so is it this part here, so? It is called a segment or a minor segment. So if over here is a minor segment, then over here is a major segment, don't you? All right. Now, anytime you have a circle with a segment and you draw something looking like two triangles in a segment, these two angles are equal. All right. So let me explain again. If I have a circle, right, and you have a segment, and this is something like two triangles in the same segment, it means that these two angles are equal. So the reason would be angles in the same segment are what? They are equal, not true? So angles in the same segment are equal. Class, you have to remember all I'm talking here for the exam. What I tell students is that because it's so much, study this thing for the last. All right. Let us look at diagram 4. Now, question, class. What type of figure is in that circle, class? What type of figure is inside that circle? How many sides does it have? 4.
4.
So how does a quadrilateral behave in a circle? Listen carefully. All right. Now, would you agree with me that these two angles are opposite each other? Is that so? Would you say X and Y are opposite? Yes. Now, listen carefully. What they say, see? They said that, by the way, this is a special name. It's called a cyclic quadrilateral. Not bicycle, you know. Cyclic. Cyclic as in circle, quadrilateral. I'm just going to write QAD for quadrilateral. All right. So anytime you have a cyclic quadrilateral, opposite angles in those quadrilaterals are supplementary. Question, what is a supplementary angle? What's a supplementary angle, class? When two angles add to give us what?
180.
180. So what they're saying is it these two angles here, X and Y, they must add up to what? 180. So for example, if I tell that this is 60 degrees. If I tell that X is 60 degrees, what is Y equal to, class?
120.
120. Because what's the reason? opposite angles in a cyclic quadrilateral are supplementary. All right? And then no, check it out now. You know what? Some students, I keep on doing this, but do you realize that these two angles are also opposite? So it works for these two, right? So that's A and that's B. All right? So let me write the reason for this now. So opposite angles in a cyclic are supplementary. Means they add up to what? 180. All right. Number 5, no. No. All right. Now, this line is called a tangent. This line is called a tangent. All right. So I think I'm gonna finish. I think I'm gonna finish this workshop with circle theorem. So unfortunately, we're not able to do any trigonometry. But you know, my next session with you guys will be Tuesday evening, so I could probably brush up on some trigonometry in that session. All right. Okay. All right. But this is very important. This is very, very important. All right. So number 5 now. Now, number 5 has the longest reason. All right. Now, what they're saying is that this line here is called a tangent. So, what's a tangent? A tangent is a straight line that touches the circle at just one point. It's like an airplane just barely touching the runway and just lifting off back. Just touches one point. All right. Now, anytime you have a tangent and a triangle, this is true. The angle on the outside, right there, so, is equal to the opposite angle on the inside. All right? Look at that. So your job now is to study these shapes. Hold on. Tiffany, turn on for me, man. Turn on that. Right. So the angle on the outside is equal to the opposite angle on the inside of a triangle. And this is also true. The angle on this outside here, so which is what? Y is equal to the angle on the what? The opposite angle on the inside. All right? So the reason is very fancy. So let me see if I can remember this. So this is diagram 5. So the angle formed between a tangent and a chord. No, hold on. Yeah, the angle formed between a tangent and a chord is equal to, it's equal, and hold on a class. let me get this right. Oh, it's equal and opposite the angle in the alternate segment. All right. So is everything right here so that I just explain to you with this? Oh, this. So this would have been the tangent and this would have been the chord. All right. So the angle formed between the tangent and the chord is equal and opposite angle in alternative segment, which is on the inside here. So that's what it's saying. All right. Okay. Let me see if I can do the other two. How do I do this? So window. All right. So all right. So that's our next diagram. So draw it quickly. Now this last one here, is the most technical one out of all of them. You know what? This thing here, it does look too let's see what I can do. All right. All right. Okay, so all right, so let us call this. So this is 5. So then this is gonna be 6. Let's call it 6 part 1. Let's call it 6 part 2. All right. So, oh, what's on? All right, so let's call it 6i and 6 part 2. All right, now, whenever you have a tangent, so this is a tangent, right? As soon finish your class? Hope you're not sleeping yet. Let me see those who are
Present.
yeah, man, you guys are burning the midnight oil. I used to have a friend when he was in high school. He used to study. Yes, yes, Alicia. I see you raising your hand multiple times. All right. All right, let me just continue before I go off on tangent. Anyways, you heard that said a while ago? I didn't want to talk about my friend with something because I didn't want to go off tangent. So that's the way the word phrase came from. You were like, you're having a conversation and let us not go off what you're doing. Tangent, right? So this is where it came from. And like, it's actually a tangent. It's a line that's going off. So, and that's what I was doing a while ago. And we're still talking about tangent. But anyways, anytime you have a tangent going towards the center of a circle, the angle form is 90 degrees. So that's a 90 degrees. So in other words, the angle form between a tangent and the center of a circle is 90 degrees. All right, so that's a reason for case. So this is diagram 6i. And what's the reason? The angle formed between a tangent and the center of a circle is a right angle. All right? All right. Now the last one is very tricky. Look at the last one, class. Wait, notice how much tangents do we have to the circle? We have two now, not true? No, and if you have one tangent to a circle and it forms a 90, if I have two tangents to a circle, how much right angle I'm gonna have? I'm gonna have two. So I'm gonna have a 90 right here and a 90 right there. That's my center. Class, would you agree with me that I have two right angle triangles? Look at it. Oh Lord. Atrocious. Atrocious. Look at that. Wouldn't that be a right angle triangle?
Yeah.
Yes.
Yeah.
And then go over here, so now we have what? Another what? What DJ Khaled said? What does DJ Khaled say?
Another one?
Another one.
Another one.
All right. So we have two right angle triangle. So diagram, this is 6 part 2. So this thing is so complicated. You know, diagram 6 part 2 has two reasons. So reason A is that two tangents to a circle forms two right angle triangle. All right, get that, class? So two tangents to a circle forms what? Two right angle triangle. All right, now watch carefully now. All right, so what I'm gonna do is by the way, you notice how when you draw the line to the center, this line here is not straight. You notice it? It will never be straight here. As long as you draw a line at this point, this is called a point of tangency. As long as you draw a line to the point of tangency to the center of the circle, you're not going to get a straight line to connect them. No, what if I decide to just take my ruler and just go so bam? Look at that. So pay attention now. Look at this now. Would you say that would you say that this triangle here look at that triangle? That's one big triangle, Joe. Yeah, no, that triangle is actually an isosceles. So these two sides are equal. And if these two sides are equal, then these two angles are equal. You get it? So this diagram is very tricky because first thing, we get two right angle triangle, and we can also get what? One big what? Isosceles triangle out of it, not true? Yes. And then now I need to mention this that these two angles right here so are always equal. All right? So hence 6 part 2 has two reasons. All right? You could also say that for reason B, so you have diagram 6 part 2 reason what? B, we say two tangents to a circle forms what? An isosceles. Get it? All right. Okay. Hold on. Let me see if I can retrieve the first image that I have first before I continue. Yeah. Let me see. Document. Zoom. Where is it? Oh yeah, capture. Okay, so I found it. Let us go to a question. All right. I will try to start with the simplest question first, and then we build up from there. Right. All right. So. All right. Oh, I need to mention something to you. Let me ask a question. Suppose, see, I have a circle, right? I have a circle. Let me see if I can draw a better circle. This thing has to go to the whole place. All right, let me just. All right, look at this. So this is a circle, right? And what I'm going to do is, I'm going to draw a triangle in this circle. All right. Now, class, let me ask a question. Look. Look at this circle. Now, tell me, what type of triangle do you think this is? I have a circle and I draw a triangle like this. What type of triangle do you think it is? And why?
It would be an isosceles triangle.
It would be an isosceles, not true. Why? Why is it an isosceles?
Sir, because the two chords wouldn't be equal in length or something like that.
Not chord, but the two radius. Is it from here, so? Right. From right here, so well, this line here will be the chord. You know? So this is it from the center to right here, so that's a radius, not true. And from right here, so to the circumference is another radius. So guess what? These two radius are equal in length because the radius of a circle does not what? Change. If the radius of a circle changes, it's not called a circle, but it's called an ellipse. All right? So, therefore, these two sides are, if these two sides are equal, then what? These two angles here are equal. All right, so I just like to make that point. All right, let's go back to the question. Okay, I want you guys to look at question 20. All right? And this is what I want you to do. This is how you answer these questions, right? Do not try to find out what these answers are down here. So try to see how much different diagrams can you get. Is it diagram 1, diagram 2? You know? So these are the diagrams. Diagram 1, 2. You know, I think I have a more prettier diagram somewhere on WhatsApp. But is it diagram 1, 2, 3, 4, 5, or 6, 1 or 6, 2? All right. So you know what? Let me start here off. So, question: which diagrams do you see in there?
Diagram 1.
Diagram 1. Yes, you are correct. So if you were to take out this line here, M to L, you would definitely see diagram 1, which is this. That's diagram 1. All right. And diagram 1 is saying that the angle at the top of the arc is twice the angle at the center. Not true? All right. Okay. So, all right, what else do you notice about this diagram? Look at that triangle in there, so. What type of triangle is MOL?
Isosceles.
It's an isosceles. Correct. Therefore, this little angle down here, so, and this little angle down here so is also going to be equal, not true? All right. Go ahead and try to answer that question now. 3 minutes. Let me tell you, man, when in the exam, don't be afraid to mark up the paper. Don't be afraid to turn the paper because these questions sometimes turn the paper upside down. You're going to examine it and some people are twist on their arm and their neck and the paper they one place, you know. And they want to twist them arm and kind of something. You can turn your paper too. Just draw and do something. All right, quickly, class. What is this angle here?
55 degrees.
55 degrees. Very good. All right. And what is this little piece down? What are these two down here, so?
35, sir.
35. All right. And this must also be what? 35.
35.
You're basically done in a class. How much marks is that? 5. That's a lot of marks. But guess what, no class? It says what? Give what? Give reasons. So you can't put 55 and 35 and expect the 5 marks. You have to give what? Reasons. All right? And you know, the reason shouldn't be a problem because you're basically telling the examiner how you got the answer. And let me just say this to you. If you can't figure out any words, try to put on some maths. All right. So it says calculate angle M and L. So M and L is 55. And the reason would be what? Diagram 1, not true?
Yeah, angle standing on the same arc.
Right. Is, well, no, angle at the center of a circle is twice the angle standing on the what? The same arc. Right. So if you can remember all of that, you'll get your 2 marks. And then no, LMO is what? 35, not true? L to M to O, the little piece here is 35. All right. And the reason would be, yeah, what you would say, you would say, let me tell you, is if you put 180 subtract 110 divided by 2, you'll get the full marks. Or you could say angles in an isosceles measure 180. Get it, class?
Yes, sir.
All right, good. Let us move on to something a little bit more interesting. Some people said difficult, but let us look at this. All right. It don't look so pretty at all. But what you notice? What do you notice, class? It is actually. Oh dear. Hold on. Do you realize it is this? It's actually this one too. 6 part 2, right? It's basically 6 part 2. So I'm gonna give you a few minutes to see if you can digest this.
What do you think it is? Is it food basket?
So what you notice about these questions is that they superimpose like three of the different diagrams in one diagram. That's what they do. All right. All right. Let me see if I can. By the way, you see how much marks this worth? How much is this? 8. So check it out. 2, 4, 6, 8. So 1 mark to get the answer, the numerical answer correct, and 1 mark for the what? The reason. All right. But as I said before, guys, you can do calculations for some of your reasons. All right. So your reasons can be working out, but not all of them, you know. Not all of them is working out. All right, so let us, in the interest of time, let us hope and pray that something like this coming in the exam. Not true? It'd be nice, not true? All right, now, would your is diagram 1? Let us look at diagram 1. Is diagram 1 in the thing? Look at diagram 1. Do you see diagram 1 shape in this diagram here?
Yes, sir.
It's there, not true? Look, let me highlight it. I'm not gonna lie to you. Sometimes teaching this online is probably a little bit better than the face to face. It's right there, not true? Yeah. So we can so whatever this angle is going to be twice down here. So all right. Yes, we had said that this is also there, not true? Yeah, man. And do you see the big isosceles? Yeah. By the way, the isosceles triangle doesn't go to the center, you know. It's only when the diagram go to the center you get the right angle. All right. So, would you agree with me that this triangle here? All right, hold on. Let me show you something. Let me show you what I'm talking about. If I were to do something like this, then you'll have the right angle triangle, not true? Did? And you're gonna have another what? Another right angle triangle over here. But guess what happened now? Guess what happened? It didn't go to the center. Sorry, it went all the way over here. So this triangle here is our what? Is our isosceles. So class, let me ask a question. If this is an isosceles, it means that these two sides are what? Equal. So if this is 70, what is this angle over here? Have to be what? Have to be 70.
70.
Right. And if these two are 70, what is this one over here? So
110. 110.
No man, it would be 40. What is 70 plus 70? 140. And you need 40 more to make what? 180.
180.
All right, cool. All right. Let me show you something. So this is a tangent, right? That's a tangent, right? When you have a tangent, all right, hold on. Let me ask a question. Look at diagram 5. Look at diagram 5. Look at it. Tangent, triangle. Look and tell me if you don't see that. Look and tell me. Do you see that? Do you see 5 in that? Tangent. And this is our what? Our triangle, not true? It's there. So diagram 5 is there also. You all see that? If you never see it, I hope you see it now. But class, let's look at diagram 5 again. What does diagram 5 say? It says the angle on the outside is opposite and equal the angle inside. Not true? So therefore, if this is 70 down here, so, all right, what is this angle inside here, so?
70.
Have to be 70, because that's what the thing said, not true? That's what it says. That's what it says. And class, if this is 70, what is down here, so?
2 times 70.
2 times 70, which is what? 140. All right? And let me tell you, you're basically finished. You're basically finished. All right? So let's try to answer the question now. So you see how I approach the questions, class? That's how you're supposed to approach the question. All right. So we want to find angle. Hold on here. Let me save this, because when I save it, I'm able to zoom in. Oh there, I won't be able to write on it. All right, let me go back. All right, it says find angle OCE. Where's OCE? Look carefully, class. You start at O, then you go to C. By the way, what is an angle? What's the definition for an angle? When two lines meet, they form a what? An angle, don't you? Right. So basically, we want to look for how many lines, class? 2. All right? We are looking for O to C, so we are looking for O to C, and then C to what? C to E. So we're looking for these 2 lines. Right? Can someone tell me what that angle is and why? What is this angle here? Let us look at the cases. I'm actually giving you the answer right now. What is it? Which case? Which reason is it? It's 6-1, no? Yes, 6-1. Because 6-1 says tangent. Oh, by the way, I'm not giving. I'm not. What's the answer, class?
Angle formed between a tangent and the circle is a right angle.
Is a right angle. So it's actually 90. Right. Very good. Right. So remember, you know, I have something like this. I have this, right, and I have the 90 on the right hand side. But if I have the 90 on the right hand side, what's the angle on the left hand side? Have to be what? The same 90, because 90 plus 90 gives you what? 180. All right. Right. So OCE is 90, and the reason would be where is it? This is the reason. The angle formed between a tangent and the center of a circle is a right angle, and that's how you get your 2 marks. All right, let's go to the next part of this question. I'm gonna erase it because it's gonna look truncated. B to A to C. So B to A to C. We said that this was what, 70, not true? And what's the how do we get 70? Because of what? Because of diagram what? 5, not true? And what's the reason for 5? That long thing here, that thing here. Angle formed between a tangent and a chord is equal and opposite the angle in the alternate segment. All right? All right. Moving along. All right. BOC. Where is B to O to C? So guys, you have to learn how to identify where them are. So B to O to C is right here, so not true? And we said that was what? 140, not true? And what's the reason for that?
Angle that the center of a circle is twice the angle standing on.
Right. It will be this. Angle at the center of a circle is twice the angle standing on the same arc. As I said to a class previously, that if you're going to examine nervous and you can't remember all of that, just make sure you put the word twice, center, and angle or something. Make sure you put in those things, all right? But do you guys realize that, well, what you could probably do, if you put 2 times 70, I don't know if that would work, if that would justify it. But I would want to think so. All right? Okay, continuing. The last one now, B to D to C. B to D to C. Oh, it's right here. And we said that, oh, that's 70. Oh, we said that was what, 40, right? Right. And the reason would be two tangents to a circle forms an isosceles. All right? Or forms, I don't know. Forms, I don't know. I don't know why it's this form. Oh. All right, subject verb agreement. Yes, it's yeah, and that's it. Let us look at one more and let's call it a day or a night. All This one is about enough. We can take 5 minutes and look at this, or less than 5 minutes. Look at this, guys. Just look at it quickly. By the way, do you see a Z there?
Yeah.
What else do you see?
Diagram 1.
Diagram 1. And also what? An isosceles, isn't true?
Yes.
Agree? Yes, man.
Yes, sir.
So it's easy. Look. So this is our Z. I shouldn't be saying Z, but alternative, right? That's our Z. And this is our diagram 1. See? And then no, this triangle here is our what? Isosceles. All right, so then no. There's one more thing there, guys. There's one more. Look. There's one more. What else is there?
Yeah,
1, 2.
wait,
Go again.
5 is there, sir.
5 is there. Right. Look at it. Look at 5. See? What does this tell us about going in the exam? You have to remember that. You have to remember the shape. I'm not sure. You have to remember the shapes and remember the reasons. So diagram 5 is also there. So if you're to look, let me highlight it. And I go so. Right. You see that? So basically, is it all of this angle here is equal to what? All of that. And this angle on the left hand side is equal to an opposite angle on the inside here. So. All right. I'm sure to post this recording in my channel. But guys, you notice that if you're to calculate all of the hours of watch time you have before exam, you know, so boy, you only have 2 more to watch them, true? Yeah. It means that you should have been watching them for a long time and going through them. But anyway, let's answer these questions. So clearly that this is 26, not true? All right. So that piece there, oops. So in here, sir, is 26. What do I do next now? Oh, by the way, hold on there. There's one more diagram there, There's one more diagram there. Do you see this there? It's there,
Yes, sir. Yes,
yeah, it's
sir.
there. It's right there. So basically, let me show you something. You see all of this? All of that is on 90. You see that? That's on 90. All right. All right. But class, if in your son, this is an isosceles, isn't true? So if this piece is 26, then this little piece here is also what? 26. Not true. And if I just tell us about all of this is 90, can't I find that little piece down here? So yeah. So what you'll do for down here so is to say it's a 90, so 90 subtract the sum of what? 26 plus what? 26. Somebody work on that for me, please.
38.
38. Can somebody second that for me, please?
38, sir.
Thank you. All right. We can also work out. Class, let me ask a question. What is all of this angle here? Would it be 26 plus 38? Let me go again.
Yes, sir.
Let me show it. Let me erase. I'm talking about right all of this. This is 26. And that is what? 38, not true?
Yeah.
What is 26 plus 38?
64.
64. Would you agree with me that if all of this is 64, then up here so at T must be what?
64.
Because of diagram 5. Are you with me? And if up here is at 64, then down here is twice 64.
28.
Which is 128?
Yes, sir.
Right. All right. I guess the answers will follow through in all this, not true? PTS is what? 64. Angle RPQ. Let me see. Where's R to P to RPQ is 38.
Yeah.
All right. Okay. All right. So in the interest of time, let me squeeze one last one. All right. Let's look at 16. Let's look at 16 and call that it. Let me give you 3 minutes to take in all of this. Oh, by the way, please don't go in an exam and say, why, sorry, no, say, them two look the same, or this look like 190. No, don't do that. Yeah? Don't go in the exam and say, boy, it's sort of fees this and look funny, sir. Yeah. 90, no, it's not drawn a scale. So don't do that. Yeah. So what you do is to identify the different diagrams. All right, 3 minutes.
Sir.
Yes?
Diagram 5.
Diagram 5. Yes, very good. Let's brilliant. Very good. I was just there looking at it. Yeah. Let us give everybody like about 2 more minutes. Yeah. Yeah. But yes, diagram 5 is there also. It is upside down here. That's very good for you to see that. That's very good. Not many persons would have noticed that. But diagram 5 is there. But if you turn the thing upside down, you see that 5 is there.
Sir, sorry for the interruption of in and out. My Wi-Fi keep going in and out.
Okay. All right.
Okay.
All right. Okay, so as Miss said, diagram 5 is there. Do you see diagram 5? Look, this is what this is diagram 5.
Sir, 4 there
Yes, very good. And 4 is the bicycle one. The bicycle one? Yeah, the cyclic quadrilateral. Yes, Donny. The 4 sided figure is there also. Awesome. So as I was saying, look, if you're to turn this upside down, class, look. I think I can turn it upside down now. Look, let me see. How do I do this? No. Yeah. All right, look, this is 5 upside down. Do you see this? Do you see this? Right here, so? Look at it. Let me show you. This is the triangle. And that is the what? The tangent.
So two, diagram 2 is in there, sir.
Diagram 2. What is 2 again? What is 2 again?
It says that forming a semicircle right hand. Yes, because right hand tangent.
No, you know why? Let me tell you why. Hold on. Hold on. Give me a minute, guys. 1 minute. All right. No, Susanna, remember say that in order for you to get it has to go straight through the center, not true? You follow? If you're to look at this diagram here, it didn't. You know what I'm saying? There's no center. There's no center. All right.
So let me ask you a question. Let me ask you a question. Right where the tangent form as P, where they have 46 plus that little piece, isn't that 90, sir?
Yeah. You mean right here, sir?
No. Alright, so you see where the angle 46 is, where the carrot goes straight over, touching the tangent. I'm asking if all of this are not 90.
You mean right here, sir? No, man. All of this is 46.
So what is the little piece? Take out the marker out there. So what's the little piece?
What is P?
No, what's the little piece that is, what is that little piece?
Hold on, Miss Archie. Let me turn on the volume. Go again for me.
Okay, so look at P. I'm asking the question. When you look at P.
T. You're saying T or P?
P. When you look at QP, say you're looking at the line that comes all the way down to QP. Isn't that a tangent?
Oh, no. No. A tangent is something that is this. This is a tangent.
That's what I'm asking you.
Yeah, it's a tangent.
Okay, that's what I was asking you, sir.
But this is not a tangent because it doesn't touch the circle.
No, I agree with you. I was referring to that.
Ms. Artie, let me show you something. You see, if the circle had a center and they drew the line towards the center, then all of that would be what? 90. But there's no center. That's the trick about it. There's no center. They didn't give a center. Let me share something. Quickly. Where is it? Before I lose it. Where is it? All right, let's look at this. Look at this question here.
Mm-hmm.
Look at this. You realize that they tell you that this line here, W to U, will be a tangent, not true?
Mm-hmm.
Notice that the line goes straight towards the center. So if
yes.
it goes towards the center, then the angle between the radius and the tangent will form a what? A 90. But if you're to look at this, you realize that what? There's no center. Is that?
Yeah.
Right. So that's one key thing that you need to look out for here.
Okay.
Yeah, it's very tricky. So the center, look at this one now, Miss Harty. Tangent to the center, so you know that's a 90. There's a 90 there.
Okay.
Yes, another 90 here, not true? Because
Yes.
there's a center. Let me see if I can find another one. There's no tangent in this one. Oh, here's another one. Tangent towards the center, another 90. All right.
Okay. Thank you.
Yeah. And you made a good point for me to just elaborate on. Also, look out for that here. You notice that case number 1 deals with a center, angle at the center. Case number 2, the semicircle, have to go to the center. Number 4 have no center at all because number 4 is talking about 4-sided figure. 5 doesn't deal with center also. It doesn't deal with center. 3 does not deal with center. All right. Okay. So let's go back to this now. So, so as I was saying, it is diagram 5 turned upside down. So it's this. So if this is 46 class, then the angle inside here must be what? 46.
46.
And then no, I have to keep on erasing because it looks, So class, couldn't we find this angle here? Isn't this a triangle?
Yes, sir.
Yeah, we
Yes,
could find
sir.
it. All right. By the way, what is this angle here?
102.
102.
102. All right. But class, let me ask a question. Remember, this is on video, so you can always rewind. So if over here saw 102, what is this inside here, so?
But you know, sir, when you turn it upside down, you get an isosceles triangle though. Because I turned my paper.
Mm-hmm.
And I got an isosceles triangle. Which would be, let me see, T-R.
Hold on it. Which triangle is an isosceles?
I would call it T-P-P-R.
Or you're saying this
Yes.
is an isosceles?
Yes.
So which two sides are equal? Or which two angles are equal?
Which two angles would have been equal?
Mm.
The R and the P, I think. Let me turn it back on. Yeah. Yes. It would be the P and the R that would be equal.
Okay. Why do you say it's an isosceles?
Why I said that, sir, it's from, I didn't calculate it out fully, but I was just turning it around and looking at it.
So are you able to prove that means these two angles are equal?
I am going to prove it. See if I can prove it, sir.
But Ms. Harty, remember we said that this was 46, Agree? From this 46, right?
Oh. So it's not, sir.
It wouldn't be and you couldn't, let me tell you, you can't look at it. You have to prove it, right? But then we said that over here so was what? 102?
Yes.
Was it 102, right? And if over here so 102, on the other side would be the supplementary of that, not true, which is 180 subtract 102, which is what? 78. So this is 78. All right. So it wouldn't be an isosceles. All right. I know you guys are tired. I am tired also. So we said that this is 46. We said that this is 78. And we can easily work out this on 2 class. Up here, so. What is that? I get 56. Is that correct?
Yes, sir. 56.
Right. Guys, isn't this a cyclic quadrilateral? And what did I say about cyclic quadrilateral? Opposite angles in a cyclic quadrilateral are supplementary, isn't it true? So therefore, this must be 100 and what? 24. All right. Okay. All right, guys. I'm gonna have to end the class now. So we're at it from 6, and it's almost 10. And I think about like half an hour break. All right. Somebody saying something? All right. So, I mean, we can figure out these, right? By now, you can figure out these and give the reasons, right? Okay, guys. So I'm going to end the session. So I will. Yes, I am going to send it to the group as it takes a while for Google to actually. Yeah, man. It takes a while for Google to send the recording. I'm not sure, but it takes a little while. So I will see you guys around. All right. All the best. God bless you.
Thank you, sir.